All right, good morning, everyone. Sorry, I was just playing with something. I hope everybody's doing well. Yesterday was such a beautiful day, and today looks like a little bit of rain and things, but should be clearing up later. So I'm going to try keeping this video a little bit shorter for you guys so that you can also do the Ed puzzle that's assigned for today. On Thursday, Mrs. Schutz and I are hoping to do a little explanation, maybe even another small demonstration, a lot shorter than the thermal one, about light energy. So today with light energy, the first thing that I'm going to have you do is to watch this Ed puzzle. I will be assigning that very shortly when I'm posting this video. And when you do that, I want you to consider these questions. What is light energy? How does light travel? And these terms and vocab words: transparent, translucent, opaque. Okay, those three have a connection with each other and mean different things. And then these two, refraction, and reflection. Okay, and so those will be answered. There'll be some multiple choice questions that you answer while you are watching that Ed puzzle, but please start with that. If you don't understand any of those terms as you're going through them, please then take notes and add those to your energy notes that hopefully you've been taking. If you're going through these and you know, or like transparent, for example, if you already know what that means, no need to take extra notes on it. Unless if you feel the need that there's something that you did not know. But we're going to talk about a few of those things here too. And I just wanted to show you, light energy is a really cool form of energy. And we had some really awesome labs and things planned for you. So we did our best to try to turn that into what you're going to be working on later this week. And so the first thing is, what is visible light? And this goes back to our astronomy or space unit when we talked about the electromagnetic spectrum. So it just says EM here, but that's the electromagnetic spectrum when we had all those different wavelengths. And so when we had those different wavelengths, we talked about how do things travel through space even though it is a vacuum. And what we came up with is that we have all these other waves on the electromagnetic spectrum going through space and even on our Earth that we don't see. Things like UV or ultraviolet or microwaves. And then we talked about the different wavelengths. Well, for the light energy part of this unit, we're going to talk only about that small little section. Okay, so here's wavelengths. You got everything from gamma rays all the way to the long radio waves. And just this tiny little section of waves is actually what we can see as visible light. These are the different colors you can see here. Okay, and this is all the light energy comes from, is right within this tiny little part of the electromagnetic spectrum. So what is light energy? It moves through waves, but as you're going to learn in the video too, it's also with particles. So it's how waves then are moving through the different particles. And the different wavelengths then are going to be different colors. And if you look here, this slide here does a great job of showing. So you have the different colors, Roy G. Biv of the rainbow, okay? And the reds, oranges, yellows are longer wavelengths, where you have your purples and blues, okay, are going to be the shorter wavelengths. And so when we see different colors, and it has a lot to do with our eyes also, because as you know, many different species on Earth see things much different, such as your dog and the difference between your dog and you and what you see as far as color goes. Okay, so when our eyes are trained to be seeing things. So when we see something, it is that light that is reflected. Okay, so for instance, the example I have here, you have the light shining on the apple, and you have all of the lights shining on an apple. When the sun, if you have an apple sitting out in the sun, all of the lights shining on the apple, but the part that's reflected to your eyes is the red, and that's why an apple appears to be red to you. But really, all of the light is hitting that. So really, that apple is actually all the colors, but what we're seeing of it is the red. And so that's how we're able to see different colors. If something is purple, it's going to be on the way opposite. Okay, those wavelengths are going to be shorter. That's going to be reflected to our eyes, and that's what we're going to see as far as light. Okay, another important thing why we're doing light energy right after thermal energy is because light energy is often transferred to thermal energy. Okay, remember, energy is never created nor destroyed. It's only transferred from one form to another. And so light, okay, as you know, for instance, like a light bulb, this is a thermal picture of a light bulb. And you can see not only does it let off light, it lets off heat as well. That is transferred through that. So you have, most of the time you have electrical energy, okay? So anything that you plug in, whether it be your cell phone, the computer that you're watching this video on right now, your TV, the light bulbs in your house, you're going to have electrical energy that's transferred to light and then obviously to heat. Okay, and so anything that you know that is light is going to also give off a little bit of heat. Okay, and same thing with fire. And then we have the sun over here that also provides both light and heat to Earth. Okay. So, when I was talking about what we see, it is important to know a little bit about the human eye. And we would have gone much more into detail about the different parts of the human eye and how it actually works. But I don't know if you've ever actually, looked in the mirror and really paid close attention to your eye and just how unique and interesting it is, and how your pupil looks maybe a little bit different than what you thought. So if you have time to do that today, just really take a really close look at your eye and see. And what's actually in there is we're going to have these different lenses. Okay, and it says the refractive index of lens different for each wavelength. So like we said, for the different colors, okay, they're going to be different wavelengths. So our eyes have these different lenses and this refractive ability to see the different colors. Okay, so cooler colors are going to be your blue, okay, which are your shorter wavelengths. And then the warmer colors are going to be further away and warmer, but they're going to be your red and yellows and oranges. Okay. And so just a little background, I'm going to share this with you guys. So you're going to have these slides if you want to ever click on these links or watch these videos. It's really interesting things. But it says most people see the red closer than the blue. Others see the opposite. How about you? So take a close look at this slide. And what appears to be closer, the red or the blue words? Okay, even though they are the exact same distance away, to my eyes, the red seem much closer. Okay, so when the two lines, most people see the red, others see the opposite. These two lines look like they're closer, and the blue look like they're further away. Okay, so see if yours is the same or if you possibly you're opposite. Okay, and one thing I've always found really interesting is color blindness. So how does that work? You guys all have probably done these tests when you're testing your vision, and you've looked at pictures like this, and they've asked you the numbers, and maybe some of you were like, yeah, I can see the 7, the 13, 16, 8, 12, 9. There's no issue. However, not everybody's eyes work exactly the way that yours do or the way they're supposed to. So if you want more information, there's some things here on the colorblind test. You can test yourself and look up. But I can always remember a cousin of mine that I was deer hunting with could never track the deer because he could never see the traces of blood where he'd have to go and find the deer because between green and red, it just looks kind of the same and kind of grayish in between. So he could see other colors, but he just mixed certain colors up. Maybe some of you have similarities to that or are a little bit of colorblind. And so if you want to know more information about it, there's these 4 links here that are really interesting and help to explain that a little bit. Another thing that I wanted to let you know, I noticed a lot of you have glasses and many of you might have contacts also. Okay, so for instance, I have contacts in right now. I think I wore my glasses maybe one day in the school year, but there's the difference between being nearsighted and then this slide's about farsighted. And this video on the farsighted does a really good example of answering a few questions, including this one. Basically, the short term, nearsighted is when our eye and the lens works in a way that we can see things close up just fine. Okay, nearsighted meaning near is okay. Like when I read, I have no issues without my glasses. So at bedtime, if I take out my contacts, I can see anything up close. I could read. But if you were across the room, I would not be able to see you clearly. It would just be a big blur. Okay, and so in nearsighted people, far away is hard for us to see. So in order for me to drive, I need to have my contacts or glasses on in order to see the road signs because I would not be able to see them. I would be able to see my speed and all that, okay, but the far away things. And then the opposite of that is farsighted. Farsighted, they can see things further away just fine, but when they're looking close for reading or anything right up close, that is going to be blurry. So again, there's more information on that in the videos, which is some things interesting. Okay. All right. So get ready for your eyes to have a little workout. Again, you have this slides, so I don't want to go too much into this because I want you to have it. If you can make it full screen, have it be your whole screen, and try some of these, or even look up some of them too. It will really work your eye out, and you can see how the wavelengths of the colors and how your eyes can perceive things differently than what you're actually seeing as far as light comes. Okay, and so for instance, this one, are you seeing any spots? Okay, I know in between as I scan through from left to right or right to left, in between the boxes, I am seeing little black or gray dots, even though there's not black or gray dots there. Okay. Another one of those, if you just kind of scan through, you'll see that all of a sudden these white dots appear to be black dots as you go through. It says, look at the cross for 10 seconds. What do you see? So try this one. Okay, kind of interesting. I'm doing it now. Are these lines straight or bent? Okay, so take a look at these lines. Here's a picture of the lines without the circle lines around it. So here they appear one way. Here they are. Okay, another one. What shape do you see? Okay, do you see Pac-Man style things? Do you see a triangle? Do you see something else? Okay, this one I always find really interesting as you go back and forth. Do they appear to be moving? Okay, this one, clearly you got the two different shapes. This one looks like a flag moving to me, even though it's clearly not wavy or moving. Another one. This one, the gears moving. There's two of these that are kind of freaky. Okay. I'm not sure why this one didn't show up. Okay. But I want you to take this picture and I want you to, so to me, it clearly looks like a frog, right? And I want you to take your head, I want you to turn and see it, this being the top, this being the bottom, and see if you can see another animal other than the frog. Pretty surprising. One thing I also wanted to point out was something really popular went around. Oh, here's one that, see if you can read this. And if you are able to read it, okay, there's something to do with there are a lot of misspellings, okay, as you can see on mine. There's a lot of misspellings showing up, but you're still able to completely read it, even though the letters are mismatched. This was a big thing that went around a couple years ago on the internet about what color do you see. Okay, some people saw gold, some people saw blue, and it all has that idea of the background and what color wavelengths that you're seeing. Okay, there's maybe a perspective of how other people are seeing it. Oh, here's the better picture of that one. Okay, now you can see what that one is. And then there's this one as far as moving. Okay, do you see a rabbit or a duck? This one I really like. This one took me a little while, to be honest with you. So read this one out loud and then read it out loud again, and then really take your time and go through each word to see if maybe you messed up. This one I really thought was interesting too. So I see a guy with glasses. But if you look, try to see if you can see a word starting with in cursive with the letter L. Okay, and kind of an interesting perspective. This one with the side view, or is it a front view of this gentleman? Some more too. So take a look at these. Okay, that's the last one. These are probably the most difficult. We had a book of these, and a lot of students weren't able to do this. These are popular. When I was younger, they had posters. People had posters of these up in their room, and you basically have to get close to it and really focus on one spot. And your eyes almost go cross-eyed, and then you slowly move away. And within these different colors within this image, there's actually some sort of a picture, and they were like kind of pop out like a 3D. So see if you can see that also. All right, so start by watching the Edpuzzle, answering those questions, and then go through these slides if you have any more questions and things. Okay, please be expecting tomorrow maybe me making an announcement about Thursday's demonstration and the assignment, and then you guys will have some hands-on things to do with light too, just from your home. I miss you all. I hope everybody's doing well. Please never hesitate just to send me an email saying, hey, how's it going, or what you've been up to. And so, all right, I'll talk to you guys soon on Thursday. Thanks for watching.